Dr. Stephen Waterhouse, aka Seven. Thank you for joining me today. Super excited to chat with you. All right, Seven, you are a founding partner of Nazare Ventures, which is an investment firm focused on AI infrastructure. You've worked at NASA, Sun Microsystems, co-founder and CTO of RPX, which is a publicly traded company. You were also a founding partner of Pantera, where you led early investments in companies like Bitstamp, Chain, Circle, Zcash, Polychain. You are the founder of Orchid Protocol, which is a decentralized marketplace for AI storage and bandwidth. And to top it all off, you actually earned your PhD in artificial intelligence from Cambridge in 1997. So AI is not something that you're kind of just now suddenly become interested in. My first question is, how did you come? Or were you christened with the name Seven, or did you decide Seven, or how did you get the name Seven?
So there's this rule about nicknames, which is you can't nickname yourself, right?
It's
you
true.
try nicknaming yourself, it just doesn't really work, right? People need to give it to you. So it was sort of a pretty simple thing. When we started Orchid, there was another co-founder called Steve. At the time, he used to go by Steve. And there's essentially like, kind of a name collision. We just both had the same name. It got confusing in meetings. So I asked one of the other founders to give me another name. And the guy who gave me the name was Brian Fox, who wrote Bash and came up with the name Bash for the shell. And he's like, I'll just call you Seven, just get rid of one letter. And I was like, perfect. So in a kind of fit of excitement and an offsite, I went and changed all my social handles. And then we got a bit of notoriety because we announced, and we were the first. We were like the first crypto company to get funded by guys like Andreessen and Sequoia and all these kind of characters, and one of the first token projects. So we suddenly had this press around us, and so my name got changed.
Very cool. I love that.
And now it's a combination. So when I'm raising money, I'm talking to LPs, or when I'm talking to people who I don't know, then I'll introduce myself as Steven. But my crypto buddies and my friends and my family call me Seven. Well, my kids don't call me Seven; they call me Dad. But
not yet. Soon they'll call you Seven. Soon.
We'll see.
Very cool. So, all right, 1997, you're at Cambridge. You earned a PhD in artificial intelligence. Like, take me back, because I mean that is such a interesting thing to be.
Yeah,
I didn't even know AI was a thing back in 1997, right? That was like when the internet was.
AI's been called a lot of different things over the years, and I guess like the sort of the 90s was this period of. It was kind of like a thawing, like a spring after this AI winter that had happened. So AI itself, there were really two, without giving a full history lesson, because I write about some of this stuff occasionally, but and you can read it there. And many people have written about this very well. So the history of this stuff goes back to like the 50s or so, where people started playing around with what were either what we now think of as neural networks, but very simple versions. First was these called the perceptron, and then there was a multi-layer perceptron, which had like a second layer of weights. The first research went into perceptrons, and then people started working on symbolic AI, which was really what became the mainstream for many years, which was more like rules-based or expert systems, not systems that learn from data. Now, systems that learn from data, people realized over time that these things had a lot more to do with statistics than was originally realized. And so by the time the 90s were along, we were applying these things to speech recognition, and we were building large multi-layer perceptrons, large recurrent neural networks. The systems I worked on, mixtures of experts, which is now being used in transformers. These systems were kind of well understood to have statistical analogies, and the training algorithms and the scale of these things were starting to be understood what you could do with them. I applied my work to speech recognition, large vocabulary speech recognition in the 90s, which was the sort of that and hand recognition were the state of the art problems. We didn't have a lot of data because the internet was this tiny thing. Right? There wasn't a web. The web only came online during my PhD. Like I remember using Mosaic and before that Gopher and FTP. So it's there was no data. And when I first left Cambridge and moved to San Francisco, our first company made a lot of its money initially from consulting for NASA. And we used things like space data, wind tunnel modeling data, Mars rover data to give us interesting data sets to work on, because the government had like crazy amounts of this stuff. Even companies didn't have that much data. And AI at that point, or we called it big data or data mining or machine learning, there's also different names for it, was your choices were go consult for a large corporation, and effectively, you could build systems around that, but that's what you were doing because they had the data, so you had to get inside somehow and get the data. Or you were working on advertising, and that's something I worked on for a couple of years during the dot-com until about 2001, 2000. You got to work on advertising systems. So in that situation, you got lots of data. But that just didn't seem that interesting to me. The idea of mining humans and using these incredible tools just to figure out how to target people better. And you'll see my later work with Orchid was really challenging this idea of what was the benefit of these big data targeting systems. Fast forward to where we are today. A couple of years ago, when I first saw the first real demonstrations of the transformers and stability in the image systems, and then later in the text systems, it became really clear immediately that we were suddenly entering this more agentic economy where the AI was going to be a tool for us, a tool to empower us and make our lives better, which is what I felt back in the days of using speech recognition. I was like, we're going to create something that thinks and does cool things for us, and it's Arthur C. Clarke robot world. So that's how I ended up in this, with a lot of different steps along the way.
Yeah. Okay. So back in the early days when you were studying AI, you did think that, okay, the future of this is clearly these machines are going to be working for us. Because back in the, when you were working at NASA and whatnot, that wasn't really, there was no possibility of the machines that you were working with being able to do that because it lacked the data or lacked the compute, or what was the limiting factor back then for these things to really kind of get to where they are today?
Mostly it was data. Compared to where they are today, the transformers have a very interesting technique they use to train, which is they don't really, there's like labeled data when you're doing things like stability with image generation or text to image, but the essentially text to text, which is like trying to figure out what to say next, is what transformers are doing, is done by just like feeding data through it. So you feed like the internet through this thing, and the output prediction is related to, it's obviously like it's a continuation. It's like a time series predictor. We just didn't have that kind of data. It's just and also there were recurrent neural networks, but the transformer architecture itself was really a very, very big breakthrough. Outside of that, the deep learning algorithms that Hinton brought in place before that, which was really like how do you train very, very deep neural networks, was another innovation. And then just the idea of using GPUs just at scale, and the kind of pipelining and the CUDA and the work that NVIDIA did to kind of knit these things together. This led to this position where you could suddenly sort of just add data, add compute, and hit this scaling law, which has mostly held true until perhaps this week, when we had DeepSeek get released. Or it's actually released at the end of last year, but the new version was released, and people are starting to understand that. So something I've been saying for a little while now, that, and is a lot of the focus of our fund, is that you can kind of think of a lot of what's happening in AI today as it's incredible. Like without saying what the results are like, it's just the results on these things are incredible. The systems are just mind-boggling what they can do. But the way we get to those systems, the way the systems are trained, the amount of compute that's required, the infrastructure investment on the hardware side, because we focus on software infrastructure, it is also mind-boggling, right? It's just crazy. And I liken this to a modern day AI Tower of Babel. So the myth from the Bible of the Tower of Babel in Babylon is that the Babylonians were trying to build this tower that just goes up and up and up and up and up, right? And the idea is you just keep building this one tower till you get to God. And no amount of investment is too big to get to God, right? I mean, like if you got to God, like what are you going to do? It's just like, okay, I ask for all the gold in the world, right? So like I'm good, right? It doesn't matter how much I invest. And so the race to AGI feels a little bit like this, in the sense that it doesn't matter how much we have to invest to get to God, right? Once you get to AGI, it's fine. You know, you've got like universal basic income, everything's solved, world hunger. You know, we find the aliens. Like it's all good because we got to God. But what if we don't? What if there are other ways to do this? What if there are more efficient ways to do this? What if there are more economical ways to do this? And so when we started Nazare, it was very much inspired by this observation, but also inspired by the work that we'd done in the, not directly, but just like the spirit of the work that we did in the 90s, where we didn't have the data, we didn't have the compute, we were constrained by a lot of basic fundamental things, and you had to get more creative. And I think what we saw the Chinese do, the DeepSeek guys, I mean, there's a lot of controversy as to what exactly has happened, but even if it turns out that some of this stuff was done with H100s, the penny has dropped to people that you could. It turns out, I mean, basically, if you look at the research being reproduced, it looks like you can do these things, and it is true, but you can do a lot more with less than people realize, because you get creative on the model, you get creative on the algorithm, you get creative in the math, you get creative in the coding, and a lot of modern computer scientists don't really know how to optimize the code.
I want to talk way more about obviously Nazare Ventures and of course DeepSeek, but before I do want to dig a little bit more deeply on your background, because it's just so impressive. Sun Microsystems, I think that you either were at a company that was acquired by Sun Microsystems, or how did you get to working at Sun Microsystems? Because I mean, that's one of the legendary companies within Silicon Valley.
Yeah, and this is a crazy time, and it's led to a lot of insights since then, and also the way that Sun worked was then copied by Google. Like a lot of the Google engineering leadership went to Sun, and the way that Sun kind of operated its businesses was actually copied by Google. So there's a lot.
In what way was it copied? Like, you say that operationally, but
it's almost like being at Google, when I spent some time interviewing there and talking to people there extensively, and their engineering culture was very, very similar to Sun. It was a different kind of company, of course, more operationally focused and less sales focused. But so we had a company in the sort of ashes of the .com. I got very disillusioned, as I was saying earlier, about advertising. I just thought this was just like a stupid use of people's. Sorry to anybody who's in advertising, but it's sort of like, it was like it's just not my thing, right? It was a personal thing. So I was like, well, I'm going to try and get really hardcore on some tech again. The AI is not what I'm interested in. What else is going on? And what else was going on was Napster. Napster was like taking over everything. The file sharing was going crazy. And this idea that you would flip the model of client server to client, like peer to peer, was this wild idea that was running through Silicon Valley and globally. Yes, it led to things like Spotify and other kind of Skype was another spin out from this period, this peer to peer movement. And one company that came out of it that I joined very early on was a company called InfraSearch, which was funded by a guy called Mark Andreessen when he was an angel, and Joel Krause from Excite, and our head of engineering was Doug Cutting, who wrote Hadoop, which was there's like a lot of like really interesting people came out of this little company in this period. So we were not able to raise a VC round after raising the angel round because all the VCs were just shutting up shop. It was like a nuclear winter after the .com explosion. So we took an offer to get acquired by Sun, and at Sun I got to work with Bill Joy, Mike Clary, and what had been the Java team and then the Genie team and was now called the Juxta team, which was this peer-to-peer research team. So it's open source peer-to-peer research framework back in 2001. So I ran that team for about a year, and then had another idea. So I came up with this idea that maybe back in 2001 there'd be lots of storage needed all of a sudden, but a different kind of storage, because at the time people thought of storage in terms of very high, fast moving data. I was like, well, what if this data was archival? What if it was things that it took photos of, videos, etc.? This is before anything was coming, before all the camera phones, before video was used, before we'd kind of put everything online. So we came up with this idea, and by doing that specific focus in the kind of product market fit from the beginning, you can change the kind of storage you need. And so, long story short, we started using commodity hardware, like just PCs and PC drives and gigabit Ethernet. And we built these clusters, and then we built a whole bunch of software that was self-managing, self-healing, really kind of like an operating system for data centers. So this kind of technology went on to be used. We rolled into a product at Sun over a couple of years. Google File System is based on the same ideas, the way Dropbox works, the way Apple works, this kind of like meta file system concept for data centers, and machines that can fail, disks that can fail, became a way that people thought of building systems. And when I bumped into Bitcoin back later on in 2013, it was a very immediate flashback. I was like, oh, hang on a second. This is what we were trying to do then. It was what we were trying to do with peer-to-peer. But now there's this mechanism through the various functions, like Hashcash and the economic security components that allow these things to work. So that was the story there.
So was this company the RPX that you're talking about?
No, it was called InfraSearch. RPX is a
InfraSearch.
different company. I've done lots of random things.
It sounds like you kind of, I'm hearing your stories and your background. It sounds like you kind of saw where the internet was going to head. But, for example, the file storage, the archival files, is that something that you just assumed, oh, well, of course people are going to put tons of videos and images online, and of course there's going to be something akin to social media, or was that?
So I'm actually trying to, to sort of, I guess, get older in my career, which is the concept of career is such a funny thing to me, but I should be more realistic, because even today when I'm looking at, especially today when I'm looking at, with Nazare, like things to invest in, my instinct or my belief as to where things are going to go is still very uncertain. I still don't quite know. Right? I'm still figuring it out. I'm still making guesses and bets and adjusting my priors and everything based on things that I learn and the smart people I talk to and the things I see. So you get lucky with your bets, right? But there's also this tendency for people they like to kind of embellish things and pretend there was some kind of straight line story from here to there, and there really isn't. There really wasn't. The concept of everything going online and everything being stored seemed super obvious, and so that seemed like just a really, really easy bet. But exactly what that was going to look like and how you were going to do it, and we also played around with before and after the gig at Sun, played around with some consumer grade online storage systems, things like Dropbox. But those guys got lucky at the right time. They did it the right way, and their interface was really good. And so you can kind of know where things are going to go, but it doesn't mean you always get it right.
Well, I mean, there's of course huge amounts of luck, but also, skill. Clearly, like you've been directionally correct on most of everything we're talking about today, and we haven't even gotten to Bitcoin yet. I mean, you just mentioned it in 2013. You kind of stumbled upon that. What was your initial thoughts and theses around Bitcoin? Were you like, oh my gosh, this is exactly what I was thinking about with the P2P?
Well, to kind of tell that story, I'll tell the RPX story in the meantime. So after Sun, I then took a bit of a detour into the intellectual property space, and initially, I guess in hindsight, I enabled the creation of one of the world's largest patent trolls. Unfortunately, which was I was a consultant. I was the top software consultant for Intellectual Ventures, and we didn't realize they were going to become a patent troll. In fact, they claimed not to be doing patent troll work initially. It was more like a licensing play. But they wised up and I wised up, and then a couple of years into this thing, John Amster, who was the top buyer at RPX, turned around and said, "Hey, let's start this company fighting patent trolls." And I was like, okay, cool. So off I went to join basically this brand new company. We were Series A funded by Charles River Ventures and Kleiner Perkins, $25 million Series A, which even in today's world is a huge Series A, and went public in 3 years. We just dominated the intellectual property space by essentially offering a product where we broke up patent litigations and bought patents before they became threats. So like zero to going public on NASDAQ in 3 years. One of the fastest growing companies of that era. After that, I wanted to get into venture. So the first step was start a venture debt fund with Eran Zur, who was the president of RPX. We got acquired by Fortress fairly early into our fundraising efforts. And we were like, hey, these guys are going to bankroll us. Let's go do this for a while. That entity is still going. So Eran's still running. That's very successful intellectual property fund. But when I saw what was happening with kind of like a hedge fund plus IP, I very quickly realized that this was mostly, I was going to end up coming over to the dark side, if you like. So that just wasn't what I wanted to do. So I think when I was bidding on the Nortel and the AT&T portfolios, and I was like, this is maybe spending $1 billion on patents probably wasn't what I wanted my life's work to be. So I just said, okay, I'm going to do something else. No offense, I'm going to move on. So I helped hire my replacement, and then I turned around to Pete Brigger and I said, hey, I've got some other ideas. I'm not quite sure what I want to do yet, but I think I'm going to go do my own thing. And he said, tell you what, come back in a couple of weeks, and if you've got a better idea, then we'll take a look at it. So I came back in a couple of weeks and I said, hey, I think we should buy some Bitcoin. And he's like, oh, it's too late. We're already buying Bitcoin. What's your next idea? And I was like, well, what if we invest in the companies around this Bitcoin thing, like the exchanges, and do venture? Because I wanted to do venture. And this idea was given to me by Sean O'Connor, who's still a very respected and OG figure in the space.
And sorry, this is in 13?
13, yeah, early Feb 13. Okay. And so I started working with Pete and Mike Novogratz, and it was still very much like on the side from my IP work. And then over the summer, Dan Moorhead came in. He'd been college roommates with Pete Brigger, and they were friends. And Dan had this successful global macro hedge fund called Pantera, which he'd sort of put on pause after the GFC, and he'd been like doing things like buying Tesla like really early and doing kind of moves like that, very macro oriented. So he got into this thing, and it went crazy. It took off. So Dan really put a massive kind of accelerant into the process. And out of the early ideas of this kind of crypto fund idea we were playing with at Fortress, we spun out Pantera. I joined as kind of a founding partner of this little team, and went on to be this beast that it is today. I think they're on. Just got an email. They get the raising Fund 5. So I worked on the two venture funds that we had at the time, Venture Fund 1 and 2. As you mentioned, I was also on the board of Bitstamp. We invested in Zcash, Circle, Civic, Chain, Brave, a lot of early things. And it was very much the transition from just Bitcoin and Bitcoin exchanges. We did a lot of local exchanges like Korean exchanges, Filipino exchanges, that all got kind of rolled up into bigger exchanges. And then the beginnings of blockchain. So when I left in 2016, it was just starting to look like Ethereum and ERC20 was going to become a thing. Gollum had just started. And I really wanted to, revisit my startup roots and have another crack at, starting my own company. I just saw like there's so much opportunity, and every time I was working with one of these smaller companies, I just wanted to be in there and roll my sleeves up and do it. And so, then I left and started Orchid, which is the next chapter.
Very cool. So when you were kind of digging into the crypto ecosystem or Bitcoin ecosystem back then, were there, the cypherpunk kind of ethos led a lot of people in those early days. A lot of people kind of understood that ethos and vibed with that. Did that attract you specifically? Were you like, oh my gosh, this is exactly so many of my views are contained within this ethos? Or was it, how did you think about the cypherpunk kind of mindset?
I think I wear more suits now for fashion than I used to back at Fortress, but the Fortress guys definitely had suits. We were, that team was the only guys with suits at the Bitcoin meetups in New York in 2013. And they really stood out. But yeah, I'd come to it with that kind of thinking process. At the same time, I didn't understand finance. I mean, I've understood finance and financial systems since then by mapping it to my understanding of crypto. So I learned crypto first, and then I understood finance after after mapping it, sort of try to understand like how things worked. And yeah, certainly like our investment in Zcash was very much driven by that thought process, is that there should be first of all, like a mimetic play around this. There should be like an understanding people will want to have something that's anonymous. But secondly, you could build systems that satisfied other things like recourse, or having an audit trail, and being able to play that kind of thing. Over time, we've struggled back and forth with this concept of what does it mean to be private, what does it mean to be anonymous online, in privacy, in financial systems. And our work in Orchid was focused around these areas.
Tell me about the early days of Orchid, and kind of what was the initial thesis behind it, and then deciding to launch this this protocol. Because you're correct. I remember when again, we spoke back in, I believe it was 17, and A16, et cetera. All these great companies that had invested, or great firms had invested in you, and it was really big. It was really the first time these major names were making a significant play within the crypto ecosystem. So it was a kind of a big shift because of you. And so tell me about the initial Orchid thesis, and how that evolved over time.
There are various things that making me think about security, and just the way that the internet had sort of security bolted onto it. I still think about this a lot. We have this sort of layer cake of systems, and security has been like very much an afterthought in many situations. And so I'd started thinking a lot about what would it mean to try and rewrite these things. And for a while, I had a deck I found it the other day, which was talking about it's kind of like a security version of OpenAI. At the time, OpenAI was actually a research team. And the idea was, what if you did the same thing, like got funding to try and rewrite the way a lot of systems were built from the ground up, in a secure way from the beginning. So that was like, hopeless naive, kind of like an interesting idea, but it was a fun little project for a while to try and think through. And then on the back of this, I started looking a lot at VPNs and the VPN market, and realizing how messed up it was, how in some ways broken a lot of the VPN systems were, and also how a lot of the actual business models of these things was to sell the data, which seemed counterintuitive to me. I was looking at the stuff, and then I kind of assumed that someone had tried this idea of what if you just tried putting a tokenized VPN together, and effectively stringing these things together in an onion routing architecture, something like Tor. And Naval had tweeted about it, saying that this was one of the most obvious plays anyone should try. And so I was like, oh, that's a good idea. And I was friends with Olaf, and Olaf's like, from Polychain, and Olaf's like, hey, you should try this with these ERC20s these guys Gollum are doing. And I looked at it and I was like, oh, that's cool. Like, yeah, we should do that. So I got some people together, I got a great team together, and then wrote a quick white paper and a couple of emails. And we went to, it was Token Summit was the name of the event, in New York. And it was the first time anyone was talking about tokens, or the idea of raising into these kind of structures. I remember Juan Bonet from Filecoin was there, and the guys from Gollum were there talking about what they'd done. And it was this real moment, and Gnosis was there. This real moment of like all the kind of early people in that space came together. And by the end of the first day, I'd raised $1 million. By the end of the week, I think I'd raised $3 million. Went back to Silicon Valley, and we had like $5 million within like 2 weeks, I think. Closed the round. And then I was like, okay, now what? We started building. And it was really fast and a really crazy experience, that period of time. We went on to raise a lot more, build a team, went through the winter that then happened, launched just before COVID, and then went back into this kind of dark period for a year with COVID happening, which then ultimately we got listed everywhere and launched a lot of stuff around the product, and we did well in the last cycle. So it was an interesting period.
It was targeted towards VPNs initially, but then it's evolved into AI and data, and just kind of a more broad protocol. Can you describe its evolution today?
Yeah, so we started off thinking, okay, well, what if we do these decentralized VPN platforms? Now, these things have been successful, and people have used them quite extensively in different regions, especially. Like it's not a great competitor to a Node or a PIA or something like that. These things are highly optimized for content streaming and for really using it like as a Netflix breaker. Right? You try and get they do a good job of making it so you can use Netflix when you're in Mexico. So or like use Binance if you don't want to look like you're in the United States. Not that anyone would do that, right? And then but when you're in a region where you have issues with VPNs getting blocked, or you want to actually be more anonymous, our system allows you to string things together, have like essentially an onion route, fire it up without a credit card, go straight in and use it immediately. You can use an Apple payment mechanism, an Android payment mechanism. You can use cryptocurrency from the beginning. And then over time, we started thinking, well, what if the nodes and the networks could do other things? What if they could run different kinds of VPN algorithms? What if they could accept this payment architecture that we built to do different kinds of transactions? And at the same time as I was looking at what I was working on with Nazare, the tech team started thinking about, actually completely parallel and coincidentally, started thinking about what if we looked at being able to string together different kinds of language models, different kinds of, switch between different kinds of image generators. Could you use these systems in ways that, for example, we're able to obfuscate who you are and what where your data is coming from, and provide these things in a similar way to say what Eric's doing with Venice AI. We've been looking in these similar kind of directions. So that's the latest thing. We've also been looking at more generalized computing platform ideas, a little bit like what ICP is doing. These kind of architectures, more ephemeral computing. So we've been looking at a few other ideas there.
So at the end of, I believe it was last year, November of, that's when you announced November of 24. You launched Nazare Ventures. Did you launch it beforehand, or was that the official launch period?
I started raising in June. Then I kind of announced the first close, which happened over the summer. And then we also had a bunch of deals that we'd done by that point. So it seemed like a good time to go public with it.
So what was the thought process around, were you thinking that, okay, there is, so I guess let me take a step back. A lot of people, including myself, and I don't know that much, but I know a little bit, nothing compared to you, but crypto AI, there's a lot of people that say that that's kind of a joke. Other people say it's the future. Where do you stand on that? Because I do see that there's some specific use cases around decentralized compute and tokenization, payments, etc. But the current AI agent meta that we're experiencing now in crypto seems pretty like not a real thing, right?
Yeah, that's interesting, right? So we're not a crypto AI fund necessarily. So it's an AI fund focusing on software infrastructure. So the things we're looking at are, it includes the concept of decentralized AI, and that's been a big theme throughout the first year or so. We've invested in a company called Vast, which provides decentralized GPU platforms with no crypto component. So it's just they have tons of demand, and they provide the capability to run GPU models mostly for inference, but now they're looking at training architectures too. Mostly high-end consumer NVIDIA chips. They have, some people do have H100s, but primarily it's like the top of the line consumer GPUs. Another example of a company that's an interesting hybrid is one of our investments called LayerLens, which is building a benchmarking service. So they have design partners now and potential clients, which include the top AI companies. And the idea is they would develop benchmarks and run benchmarks for LLMs, and the LLMs would be run by people in what in crypto we call a deep in architecture. So in an incentivized way. So these are some of the things we've been looking at. We've also been looking at sort of much kind of like hard math problems, like one company called Hellas, which does a mechanism to prove whether or not a GPU or a particular graph was executed. so in a decentralized network framework whether or not something was actually done in the way you thought it was going to get done and what you paid for. So those are some examples which span primarily the ideas of decentralized AI. But we're also looking into new model architectures, new algorithms for training, decentralized or otherwise, fully homomorphic encryption, and then been looking at agents for about a year. But most of the agent work we've been looking at is exemplified by guys like Agent Ops or Crew AI, which are, I guess, kind of like what I call like the San Francisco AI style of agents. I was tracking the Truth Terminal work as it happened, and I'm very interested in what has become this agent meta you mentioned. The ELIZA framework is actually pretty interesting, and there's some it's an interesting kind of agent launchpad framework. The shade on the sort of crypto AI aspect is that we tend to run very quickly towards monetization and financialization of these architectures, and kind of almost like the whole thing is sort of a mimetic kind of joke. What I'm very interested in is what happens when these decentralized agent frameworks collide with some of the work that's happening by guys like Crew AI, right? So Crew AI, they have an agent framework. I think it's like half the Fortune. An old friend of mine actually is the COO. Is half the Fortune 500 uses that framework. Right? Compare that to the crypto stuff. It's just like kind of silly, right? It's like feel like a toy. But these toys, sometimes when you start combining them with really interesting things like real world things, can have real utility. And I think that's the pipe dream that many people who are looking at these things have in the decentralized space. The challenge of decentralized systems and crypto AI is that you have to try and get past the, what do I call it, like a sort of this utopian save the world meta. Like how do you think about these things as creating actual value and actual products and move beyond the big AI is bad, right? Like I have to do this because I'm compelled by a higher power to stop the big AI, and it's like no one really cares. I mean, yeah, I care, but no one really cares. You can't make people care to use decentralized systems. There's not enough people, and I fought this privacy battle for many years and decentralization battle. There aren't enough people who will just do that because they sit there and go, well, yeah, I really should, like fight the big AI, but they just use the product in front of them. They use the TikTok and they use the Instagram, these whatever. Even though TikTok's a Chinese company and they probably shouldn't do it, they just do it anyway. So you've got to find some use cases and some systems where using a decentralized platform is actually better. It gives you something you couldn't do otherwise, or it's actually cheaper, or it's actually more powerful. And that's the challenge in general with decentralized systems and business models associated with them, and specifically within this framework and ideas.
So what role, in your opinion, do tokens play within the crypto AI world? Because, I don't know, decentralized compute marketplace that you spin up and you say, hey, people that provide our compute, we're going to pay them in their token that we just created. And then we'll create some, inventive syncs and mechanisms to hopefully increase the value of that token. But in your opinion, what role, because you're right about, AI agents in crypto is like AI agent that tweets and we attach a coin to it versus Crew AI, which is used by, major companies that are doing actual work. So yeah, in your opinion, what role do tokens play within this world of AI?
One of the challenges with tokenized architectures and business models, a couple of things. One is just that like crypto is a scam, right? That's the thinking process. Don't take me out of context on that quote, but it's like the AI community came up during a period where we were going through FTX, right? And so a lot of the instinct is just like, this stuff is crazy. These people are crazy, right? And we're not doing ourselves any favors with the meme coin world, right? It's like, oh my God, the new president just launched a meme coin right away. It's like, it's actually it feels like a simulation. If there is a thawing of some of the very harsh regulatory oversight such that crypto incentivized architectures and frameworks are easier to launch and need less regulatory concern, or just like less legal bills to get done, then you can start. I mean, I think like Chris Dixon wrote this very well in his book, Read, Write, Own. He talks about the way that you can cold start these systems very easily. If you look at the way the eigenlayer works, you have systems where you can go from zero to an incentivized network where people will run these nodes. For example, the benchmarking service I was mentioning, the partner with eigenlayer. And that's actually quite tricky to build otherwise. If you try and do that in a non-tokenized architecture, it's pretty tricky to get one of those systems to be up and line, right? Think through how you do it. Like how do you incentivize people? What are you going to do?
So obviously incentivization, capital formation, that makes sense. But really you're talking about kind of more deep in where it's, building out vast arrays of infrastructure through incentives and through, basically people and community. Is that roughly what you're?
Yeah. So like going back, right? If you look through the mistakes that were made in building the first social networks, like I knew the guys who started Friendster, right? It was like, these things just like were silly. The engineering didn't work very well. It didn't scale. This happened, that happened. It wasn't secure. Then MySpace was kind of like sort of like, it's kind of okay. Flash in the pan, sold for like 500 million, which seemed like a huge amount at the time. Then all of a sudden we had Facebook, right? It just took over, right? They got everything right and it just worked. So I think a lot of the things when you look at these systems that should make sense, like deepen, like incentivized frameworks, incentivized network frameworks, it really should work if you really think it through. And it makes so much sense as to why it should work. And it's kind of working, and Helium kind of worked, and it's starting to work better now. And Filecoin's kind of working, and things are like sort of getting there. I think that we're at the verge of these things actually working and actually becoming very successful. And then you'll look back at these early versions and you'll wonder like what the big deal was. Why didn't everyone just get that from the beginning? And there's sort of inflection points that I think we're at with a lot of things in decentralized, in crypto and tokenized architectures. I think that was one of the sort of fundamental thinking processes around doing a fund, is that this is the moment where the last 12 years I've been in it will actually feel like that was just the starting point, and this was just laying the foundation for what happened next. And what happens next is mass market adoption, and it not like everyone's using it for Starbucks, but the real crypto AI intersection is all companies will use some form of crypto and all companies will use some form of AI. That's the intersection. We don't need to stick these things together and try and make them into something. Understanding both things will be important for the way that companies are built in the future.
And purely from the standpoint of more efficiency makes sense versus like, hey, we're going to plug a token into this, new application because of these, funny reasons, right?
My partner's Norwegian, and we were in Oslo talking to some friends who work in traditional finance in Scandinavia. And one of the guys had a few drinks. He was baiting me into defending Bitcoin. And after a few minutes of talking about it, I was just like, you know what? I don't need to do this anymore.
Yeah.
This thing's okay. Like whether you bought some or not, I don't care. But you should understand it. Like don't buy it. Just understand it, because it's gonna be important to you one day. And I think that at this point, it's not about will it survive or does it make sense. It's more like this is a component of systems that you can use. You can choose to use these kind of systems to build applications. They'll have pros and cons, right? You want to use more or less decentralization. You'll want to use different kinds of ways of doing it. But people will start to understand what these technologies can do in the same way as we're now starting to understand what AI can do. And that's what I'm looking forward to this next period, assuming that a lot of the conversations and the narrative around kind of the brakes being taken off. At least the US government's not going to try and destroy crypto every day. They may actually just try and understand it at least. That I think gives these systems, these companies and these kind of things a chance to shine and show that there's a lot more to tokens, crypto, blockchain, whatever you want to call it, than just yet another financialization layer. That's yet another way to trade.
What are some, if you could kind of wave a magic wand and make these come into being, what are some protocols, products, etc., that utilize DePIN or AI, crypto, etc., that you want to be created or that you wish were alive and running right now?
I'm very interested in that. There are some investments that I've made, and there's some systems coming along now in decentralized training, which is this fusion of a new kind of AI training, which is more like federated learning, and then having systems and people incentivized to build parts of a model and then form these things over time into larger ones. I think that's fascinating for the AI community to unpack and understand and do lots of innovation around training. I think what happened with DeepSeek this last week has really made people start thinking about that more carefully. I think prediction markets are fascinating, and I'm looking forward to seeing more of those kind of things, perhaps even seeing those extended into derivatives and being able to do, microinsurance. I want to build a prediction market around whether or not my crop is going to be successful in the future. I'm a farmer. Like, can I do that? How does that apply to microfinance in not just developing parts of the world, but just in sort of smaller communities? The bureaucracy associated with unlocking capital and unlocking small lending markets is just astonishing. It's just it's almost kind of criminal. I think we'll look back at this period as almost like the same way as we look back today on the Middle Ages, where people just move pieces of paper around. Right after the printing press, it's not Middle Ages, but after the printing press, people just like move paper around and like wrote things down, and then that's how they kept records. And that seems so antiquated today, but yet we're still doing a lot of those things. People have one system over here, another system over there, and they do something over here, and they type it in there, and they don't connect these systems, the simplest things. So I think a lot about these mergers of blockchains and tokens, and then also AI, and even just improving the plumbing between systems. I think that will also make life a lot better.
Pertaining to the decentralized training, that's important because it democratizes training to not Google and Meta and et cetera. But then there's also DeepSeek, which apparently not a lot of funding, and we're able to get these incredible results. So I guess, why are you excited about the decentralized training specifically?
It's more like open source models that allow you to then marshal distributed resources, right? So 5.5 million is still actually a lot of money for a lot of people. And that's supposedly what it costs, right? I don't have like any idea about, like, I don't have like 5 of my sitting around to go like train a model. But like, if I collected a bunch of people together, I don't know, let's say Portugal wants to build a model, right? How do they do it, right? Do they have where do you get the nodes from? Okay, got to go buy a bunch of these nodes. Like, damn it, like, where is it? Where do I put it? Okay, hang on, who's got some, right? Well, lots of people have nodes, right? Lots of people have GPUs. Can I pay for those things? Yes, I can. Okay, well, can I get the data to them? Yeah, that's no big deal. So you can like get all these things together, and then that provides essentially this framework for doing it. Distributed training it's not just about the sort of study at home model, which is fascinating, and the democratization, but it's also the idea of, how do you make compute more efficient? How do you make access to compute more efficient? How do you standardize the way that you build models, execute models, build resources? I think, and that's what fascinates me about it.
What was your reaction to DeepSeek? I mean, the video, I think, was down like 15% yesterday, which is just absolutely massive. I think it was like something like 600 billion or something. But
I wrote a long piece on this. I have this newsletter called Robot Wave, hence Nazare, right? It's AI Wave. It's just Robot Wave on Substack, and so I wrote this piece that's called "Make AI Cheap Again" or Matcha, and the narrative there is something I've been talking about since we started the fund, which is that it's not just about going back and seeing what you could do with different models and this sort of Tower of Babel thinking process. It's also inspired by what we talked about with Sun. So when Sun Microsystems, they were the so-called .com, their advertising campaign, this guy, Scott McNealy, he was like a modern day kind of Elon Musk kind of character, just like very swashbuckling, incredible CEO, like real personality. And he he had this expression, "We're the dot in .com," like basically meaning like, we're like the core of it. And when you were out raising money, there was a couple of things you needed. You needed a Stanford MBA, you needed a really good PowerPoint, you needed a deal with Sun, EMC, and Oracle. And then you had your idea. The idea was this other thing that you worried about later. And you got money, right? And most of your money initially just went into the hardware, the software, and the licensing for the storage and the systems. The idea at the time that you would build anything other than using these big Sun hardware systems and their proprietary software was crazy. No one would want to do that. But meanwhile, there was this bunch of people like myself working on commodity hardware and open source software and realizing you could build web systems without this thing. And then that's what we did at InfoSearch and then at Sun. And then that's what became the internet. The internet today is run on Linux. It's run on commodity hardware. It's run on PC architectures, AMD or Intel or others. And that shift happened very, very fast. And the trigger for it was the dot-com bust. But the technologies were there already. So it wasn't like someone had to invent these things. The systems to do it were there already. And so my theory is that, and a lot of people's theory now is that NVIDIA has this dominant position on the high-end H100, H200, incredible technology. A lot of the technology is based around the chip-to-chip communication, so it makes these models extremely efficient to train. You build these clusters that don't even use gigabit Ethernet, they use InfiniBand, it's like super special networking technology. And then you throw these things together like XAI did, and off you go. You get an LLM, the supercomputer thing. So what some people have been doing recently, like Noose Research and Prime Intellect, is demonstrating that you can build these decentralized training models. And that's not just the decentralization of it, it's the fact that they're doing it across heterogeneous hardware. So it's not just homogeneous hardware where it's the same chipset, they're using different kinds of machines. And they're connecting them across wide area or across gigabit Ethernet. And so the beginnings of this idea of that you could use open source software on different kinds of hardware was already there. What we were talking about with the matcha thesis is that it's very unusual that hardware wins. Usually, like in Mark Andreessen talks about, software eats the world. And in this case, the software and the market finds a way around it. And I think paradoxically, the freezing of the export regulations for the chips to China and other parts of the world made it so that, mother was the necessity of invention. So you had to go out and figure out a way to get around these things. And luckily, there's like 3 or 4 decades of AI research, which has had people thinking about things like quantization, which they used, mixtures of experts, which they used, and then reinforcement learning, which was a kind of a new twist on it, but ironically based on the chain of thought architecture that came out of OpenAI and their work. So these 3 combinations together then led to these incredibly impressive results. They open source the tech, they open source the models, and everyone loses their mind. So, and quite rightly so, because all of a sudden there's this challenge to, what's happening, and maybe the emperor does have no clothes, maybe he doesn't, maybe he has some clothes on, but there's definitely like they've cracked open a niche in this armor that suggests that there may be other ways to do it. Now, it doesn't mean that NVIDIA collapses tomorrow, because they'll still carry on selling these systems. In fact, ironically, the chips that are being used instead are also sold by them. But the sales structure of the sales team is different. So you no longer want to sell to like 20 companies. You actually want to sell more like Dell does, like just anyone can go buy one of these things. So it's like the way that they're organized may have to change. It may open the door to other competitors. Maybe AMD will actually try and figure things out finally. Maybe they won't need CUDA. Maybe Apple with their architectures, maybe Google. There'll be still a more of a crack in the armor of how you build systems, because it's like in science, until somebody proves that you can do it just once, everybody believes that everything has to be done a certain way. And then as soon as somebody publishes that you can do it that way, suddenly it's obvious and everyone's trying it.
Is your opinion that the Mag 7, these companies are spending, an inordinate amount of money and kind of in a wasteful manner on infrastructure? Or do you think that the GPUs will actually be all utilized? GPUs, data centers, etc.
It's a funny one, right? Because it's actually quite different to the fiber optic build out, for example, or the telecoms build out that happened in the internet period, the internet build out, because a lot of that tech got used for a long time, whereas GPUs have a sort of a shelf life. They have like a life cycle period where they're the top dog, and a period when they're not. Um, but if there are indeed ways to use chips more efficiently and use systems more efficiently, then that'll just mean that we actually now have more capacity than we thought we did. So suddenly I can actually do even more than I thought I could do before. And then maybe we'll start hitting different bottlenecks and different ceilings. Maybe data is suddenly the issue. Maybe we need to find new forms of data or synthetic data or different ways to collect data. Maybe the challenge.
Yeah. So would you say it's kind of an overreaction? Because in my opinion, and again, I know very little, but it just seems like, okay, well, now we have more compute to focus on other things versus, we just became way more efficient. Now we can tackle robots and, other harder challenges.
Things are rarely as bad as they may seem or as good as they seem. I think that it's an appropriate reaction given the level of misunderstanding as to what was actually happening in these systems. People tended to put NVIDIA on a pedestal, and they will continue to be a very important company, and continue to be extremely profitable and dominant in many ways. There is definitely a challenge for them over time as to how they transition their business. And they even talk about it, like what happens when compute goes to the edges? What happens when you can do more with less? Even if the model and the training architecture hadn't sort of effectively just changed and people start thinking about different things, you'd eventually get to the point where you could do more with less. And Jensen Huang has talked about distributed training, and he's had like Ilya from NIA talk about just decentralized AI. There's an understanding that these systems are out there on the horizon. The problem is, and this is what we face with Sun, is that remember Sun innovated. They created Java, right? So like they created J2ME, which is the first real mobile operating system across platforms. So they understood what the future was going to be. The problem is that they could not like turn the sort of aircraft carrier of a sales force and organization, which was just printing money on the back of these massive servers. That couldn't move. No matter how much understanding they had Andy Bechtolstein, they had Bill Joy, they had Mike Clare, they had all these like incredibly good insight, and with Diffie, like they had like an incredible collection of engineers and visionaries who understood where the internet was going to and where the markets were going to, but that was being funded by these massive server sales. And right now, NVIDIA probably understands, and there's probably people there who I don't know, but they just probably understand what's going to happen, but they're being funded by these massive H100, H200 sales that they're just really hard to say no to.
Looking forward, how do you expect Nazare Ventures to evolve?
We're deploying now. We're still talking to some investors and raising into the fund. This is not a request for funding. I'm not pitching the fund right now, but we are deploying. We've done some very interesting investments. Continuing to focus on, in general, like new waves of infrastructure, especially software in AI. And as I mentioned before, we've done a lot of work already in decentralized applications, and we continue to be very interested in that. I think that we'll tend to stay, kind of on the smaller side as funds go. My primary reason for doing this fund was that I like working with founders. I like working on early stage investments, and that's where my heart is. So when you build things too big, you tend to get away from that. So I wanted to stay close to it.
Very cool. All right, Seven, are you ready for the rapid fire closing questions? Alrighty. What is the best piece of advice you've ever received?
Be careful of receiving advice. Best piece of advice. Yeah.
That's a good one.
So that actually goes back to on point. I don't know if it's the best piece of advice, but probably the best bit of career advice was. So I was at Foundation Capital in just after Sun, and I really wanted to be a VC. But I was working as kind of an entrepreneur in residence, sort of associate partner, like hanging around the hoop, as you might put it. And So finally, I just started getting explicit about it, and I was just like, guys, you guys, 6 months, I was like, you guys just give me a job, like just bring me in at the bottom, I'll work my way up. This one guy comes up to me, and so one of the partners I was talking to, and he's like, you know what? Because let's have a chat. Because you really haven't done anything yet. And I was like, oh, but I've done this and done. He goes, no. I'm talking like, if you were to sit with a founder right now who's raising money, could you look him in the eyes saying, I've been where you are, I've done what you've done? Or if I haven't done it, I know the guy who has, or like, I've done something similar. Like, have you taken a company public? Have you done this? Have you done it? Like, can you actually help this person because you've done it? Or are you just a guy who knows about it because you've read about it or someone told you about it? Because they're two very different things. He said, until you've done that, for a guy like you who likes to build things, you should keep going. And then once you've done those things, see whether or not you want to be an investor. And I still think about that because you work as an investor, especially with early stages, you're in a very privileged position because you see a lot of things, you get to work with incredible people, but you're also in this position of responsibility because people look to you for advice, they look to you for help, and you better know what you're talking about, right? And that's been something that's really stuck with me.
All right. When do we achieve ASI and do we survive?
These are all like very weird things. Like, what does it mean? Is it self-improving? Like, what is the threshold? In many ways, we've already passed the Turing test. About like, if you went back 20 years, your definition of the Turing test would be like, okay, fine, this thing is definitely a Turing test winner, right? I can't tell the difference. And so what is the threshold? Like, what is the definition of an ASI? Is it self-improving? Is it aware? What do we mean by aware? Is it conscious? What does that even mean? Does it somehow have, like, should it have rights? I don't know. There's like a really strange thing, right? There's kind of almost this concept of, as you get closer and closer to this threshold, it almost seems like the definition changes and it gets almost like further away or stays the same distance away from you. I think we'll certainly see very sophisticated systems in the next 5 years that by today's standards, we will probably think of as some kind of AGI. So within 5 years.
What type of functionality will those systems be able to have?
The performance on fixing like Jira tickets, right? So this is one way to think about it. The best systems are doing, somewhere between 5 and 20% accuracy, right? In terms of like, you give them things to fix and they fix them. But they're getting better, right? And the question is like, once you get to near 90% of accuracy in terms of being able to fix code, then can you plan and say, I want to build a new piece of functionality, and what should that functionality be? Can you marshal resources which can then improve your system and self-improve? How do you get resources to do that? How do you think about fixing kind of like a self-improving mechanism, right? That's one of the characteristics that we have as humans, and that's what we're looking for when we're building agents is an adaptability, a learning mechanism, a self-improving mechanism. You don't want your assistant to carry on being as stupid as they were yesterday. You want them to get better. So essentially, we're kind of incentivizing that behavior, and we want these systems to improve. So I think there's a natural tendency then for these agentic architectures that we're building to have that characteristic to the point where over time they'll feel more and more like interacting with a person. You'll fire up a system, you say, hey, can you help me out? You have your Jarvis or your kind of equivalent. And whether that's AGI or whether it's just like an extremely smart assistant, again, it'll be a definition. We'll be questioning that. Until the point where maybe we don't question it anymore and we just kind of take it for granted.
Yeah. Wow. 5 years, huh? That's pretty it's pretty soon.
Overhyped and underhyped. I don't know. I think everything's underhyped.
Sorry, you said you think everything is underhyped?
I think in some sense I feel like we kind of underestimate technology in general. I think that I'm really in the camp of over a reasonably long arc of time, as long as we don't screw ourselves up too much and blow ourselves up, technology actually fixes a lot of the problems that we have today. And I think that, for example, like we looked a lot, the kind of the population explosion was overhyped, right? I'm certainly not a climate denier, and I'm definitely like very. I mean, I invest in a climate tech fund, so I'm like not a denier in any sense, but I'm a technology optimist when it comes to climate, when it comes to systems, and I think that accelerating into these areas and allowing people to really experiment with technology and try to engineer solutions to systems is underhyped. We should do more. We should try harder in those areas, and that's really. I tend to be an optimist around these things. And underhyped, AI warfare, drone warfare, I think is terrifying, and I'm actually scared of it. Yep. Self-assembling weapons.
Yeah, no.
Those things scare me.
Like nanobots, or you mean just regular self-assembling?
I was actually rereading recently called The Ministry of the Future, Ministry for the Future, by Kim Stanley Robinson. It's about climate, and in it he talks about how in the future there really isn't the same concept of warfare, and it's very near future because missiles just assemble and then land, and so you can't actually defend yourself because they come from wherever, right? And then they assemble last minute and take you out. So you can do a lot of things with like advanced technologies and automation.
All right, last question. What is your proudest accomplishment?
My children.
That's fair. Love it. All right, Seven, man, thank you so much. This was incredible. I absolutely love learning from you. And if people want to find out more about you, learn more about Nazare, where should they go?
Website is nazare.io, and I am it's just Nazare VC on Twitter.
Amazing. Thank you, Seven. Appreciate it.
Okay. Thank you. Cheers. Bye-bye.